Today's video is about misleading statistics. It's found in your 4B packets on page 1. This is video 5, misleading statistics. So have you ever seen a vacation advertisement that appeared too good to be true? Was the ad misleading, or did it not give all the information? As a selling strategy, advertisements sometimes distort the facts by taking images and words out of context or by leaving out important information. Similarly, when you are given insufficient background information or an incomplete picture of the data, you may be looking at misleading statistics. Whenever there are outliers in the data, the mean is not a good way to describe the data. When there are outliers, you should be using the median. We talked about what best measure of central tendency to use. When there are outliers, that's the median. So here's an example. Amara is interviewing for a technology company. She is told that the average salary of the 37 employees is more than $40,000. Using the information at the right, should Amara expect a salary of more than $40,000 if she gets the job? Explain. Well, I can see that there is a president, one of those, a vice president, one of those, and their salaries are much higher than the salary staff or the sales staff, the secretaries, and the phone ordering staff. There are 15 staff, 10 secretaries, and 10 phone ordering staff people. So that's a total of 37 employees. So out of the 37 employees, 10, 20, 35 of them have a salary of 35 or less. So I would say no, because 35 of the 37 employees, would she expect to get $40,000? No, because 35 of the 37 employees make less than $40,000. It's the president and the vice president that skew the mean much higher because of their salary being so much higher. So they make much less than that $40,000 that they said. Oh, our average employee makes $40,000. 35 out of 37. So she should expect to make less than $40,000. The president and the vice president are considered outliers. Their salary is much higher than the others, so they skew the mean to a higher average. The median actually would be the better indicator of about how much Amara is going to make. So that would be the 18th number from the salary line here, which would be somewhere in this range. The median, she should expect to make about $16,000, not what the average of the company is, which was $40,000. So that's a misleading statistic to say the average of our employees is $40,000. Here's another example. Graphs. Be very careful of graphs. Look at the scales of the vertical axes. That's the hint. So in a bar graph, show the percent of viewers of watching a network television. Which graph could be misleading? Graph B here. Notice that the y-axis is misleading. The scale on the y-axis doesn't start at 0. Does not start at 0. So it tends to exaggerate the changes from year to year. It accentuates because the scale is actually smaller. It's counting by twos. It makes it look like from year to year that, oh my gosh, we're losing a lot of viewers. We've got to do something. We've got to create a new and cool television show to get our viewers back. But if you really, I'm sure the data is, the more true data is graph A that says, oh, you know what, we're pretty consistent as a company. We've had approximately the same percentage of viewers over the last 10 years from 1987 to 1996, for instance. So because the scale has a different interval and it doesn't start at 0, graph B would be considered the misleading graph in this instance. So when you're looking at bar graphs or graphs in general, look at scales. When you're looking at data, look to see if there's outliers. Page 2. Biased and unbiased sampling. So if you wanted to conduct a survey, you want it to be unbiased, not favoring one of the outcomes that you're looking for or the question that you're answering. You don't want, to only ask people that are coming out of, cheeseburger, oh, what's your favorite hamburger place? Because they're probably going to say cheeseburger, right? So you want to make sure that you're asking an unbiased question in an unbiased way. So to get valid results, a sample must be chosen very carefully. An unbiased sample is selected. This should say unbiased. In case you can't read that, that's the word UN right there, those letters. Unbiased sample is selected so that it accurately represents the entire population. 2 ways to pick an unbiased sample are listed below. Unbiased. So a simple random sample. Each item or person in the population is likely to be chosen than any other. That's what you are looking for. So how could you do that? Well, I do that in class. I have your little name cards. Everybody's name is on one card. I randomly shuffle them up, and I pick a kid's name out of the name cards. Or writing each student's name on a little piece of paper, putting them in a hat, pick a name out of the hat without looking. That's a simple random sample. Another way of doing it is a systematic random sample. Key idea here is that it's random. The items or people are selected according to a specific time or an item interval, such as every 20th person is chosen from an alphabetical list of all the students attending a school. So we want to ask them, what's your favorite item on the lunch menu? We could do that. Every 20th person chosen from the alphabetical list of students. We could stand outside of the doors, kids coming in the morning, getting off the bus, and ask every 10th person student coming into Martha Brown, what's your favorite item on the lunch menu today or any day? But it wouldn't be an unbiased sample if we were in the cafeteria and we were asking kids on taco salad day, what's your favorite thing on the lunch menu? Because they're going to smell tacos and, and it's only kids that are in the lunch menu, maybe in the lunchroom. Maybe that day some kids decided to buy their lunch, so that wouldn't be a very random sample. So you want it to be random either by simple random sampling, everybody has a chance of being chosen, or like every 10th person or every person whose first name begins with the letter A, chosen out of the alphabetical list of the students at Martha Brown, or just every 20th student, even better, because not everybody's name starts with an A. That might be biased. In a biased sample, one or more parts of the population are favored. 2 ways to pick a biased sample are listed below. Oh, it's convenient, you only ask people of, the population that you're around. Like, okay, you might go to the cafeteria after school and say, hey, what's your favorite sport? And you're only asking the kids who play soccer or football, and it's in the fall. and those sports are the ones that are played. So that's kind of a convenient sample because you want to ask kids about sports, so you're like, I'll go to, sports study hall after school and ask kids. So that's convenient. It's going to be biased towards people who are right there in the cafeteria. Or it could be the principal only asks students in one math class. Well, what if it's only sixth graders? What if it's only a math class of really, really, really smart kids? Or what if it's a math class that has students who don't like math and he's asking them, what's your favorite subject today? That would be a biased sample. They're probably going to be like, I don't like math. But of course, everybody loves math, so they wouldn't answer that way. Another one would be a voluntary response sample. A voluntary response sample involves only those people who want to participate. So you send out a survey and you say, well, you can fill it out or not. Well, you might not get people to fill it out. And it might be people who are very passionate about whatever item it is that you're trying to get a sample about. So if you wanted to get an exit poll at the election, and you're only asking people who voted for, let's say, Hillary Clinton, you might get a very passionate response there. So, or it could be students at school who wish to express their opinions only to complete an online survey about, having ice cream every day on the lunch menu as a thing that you get. People who like ice cream are going to answer that survey. So you could have a biased survey result if you have a biased sampling way or a biased question. So you got to be very careful with your method of sampling. The key idea is to make it random as possible. Then it will be unbiased. So here's some examples. Determine whether the conclusion is valid. It's only going to be valid if it's unbiased. It's a good question and it wasn't done in a biased manner. So justify your answer. A random, keyword there, a random sample of students at a middle school shows that 10 students prefer listening to rock, 15 students prefer listening to hip hop, and 25 students prefer no music while they exercise. It can be concluded that half of the students prefer no music while they exercise. Well, first of all, 25 out of 10, 15, 20, 25 out of 50, 25 in this little survey said, I don't like to listen to music. So they said no music, right? Well, that is half. And this sample was done in a random manner. So I would say that this is valid. Yes, you could conclude that this is a valid result because half did prefer no music. So you could say, at Martha Brown, half of our 850 students prefer no music when they exercise because I did a random sample, and in my sample, half of them said they don't prefer music. It's valid because it's random and the result is the same percent. 25 out of 50 is a half. Okay, let's go on to number 2. Determine whether this conclusion is valid. Justify your answer. Every 10th person who walks into a department store is surveyed to determine his or her music preference. Out of 150 customers, 70 stated that they prefer rock music. The manager concludes that about half of his customers prefer rock music. So every 10th person, that's a random sample. That's a good way of sampling. So maybe the manager wants to know, what kind of music should we play here while, our customers are shopping? 70 of them stated that they preferred rock music out of 150. Well, 75 out of 150 would be 50%. That's about half. 70 out of 150 is about 46 2/3%. I believe that comes out to be. So that's pretty darn close to 50%. That's about 50%. So again, the result of the sample matches the conclusion, half, about half, and it was done in a random manner. So the result of the sample is approximately 50%, and it was done in a random manner. So I would say that's a valid conclusion. Next page. The customers of a music store are surveyed to determine their favorite leisure time activity. The results are shown in the graph. The store manager concludes that most people must prefer listening to music in their leisure time. Well, the customers of a music store, that's a bias. You're asking, that's a convenience sample. If you run a music store and people are at the music store, wouldn't you think that they like listening to music in their leisure time? I would think that that's a biased sample because it's not random. So is this a conclusion? The store manager concludes that most people prefer. No, not a valid conclusion. Because it's a biased sample, a convenience sample. It's not random. And he should, if he wants to know customers at a music store, if he's the manager of a music store, he might want to go to, say Tops or Wegmans and ask every 10th person that comes out of Wegmans, hey, what do you like to do in your leisure time? Do you play sports? Do you hang out with your friends? Do you listen to music? Do you play video games? Like you might have certain things that people could check off. But if you're going to ask people in a music store what's their favorite leisure activity, they're probably going to say music, right? It's not a convenience sample. It is, a convenience sample. It's not valid because it's not random, and it's really not asking, a conclusion of the general population. A store sells 3 types of pants: jeans, capris, and cargos. The store workers survey 50 customers at random, okay, so must be people who come into their store, about their favorite type of pants. The survey responses are indicated at the right. If 450 pairs of pants are ordered, how many of them should be jeans? Well, you want your customers to get what they're interested in buying, so you're going to want to take a look at the results of your survey, because that's what you want. You want to know, do you like jeans, capris, or cargos? So there were 50 people total in the survey, and now the manager is going to order a total of 450 pairs of pants. Well, 50 times 9 would equal 450. So I need these results pretty much to match. I want to order as many of the kind of pants that people want as possible. So if I just multiply by 9 here, I would get 225. And 15 times 9 would give me 135. And 10 times 9 would give me 90. And yes, that would add up to 450. How many of them should be jeans? Oh, 225. Oh, could have done that way easier. 25 out of 50. Hello, that's half. Right, that's half. So 225 out of the 450 would also equal half. So how many should they order? 225, right? You want to give your customers what they want. So that's taking a survey result and making a prediction about the future based on your survey results. 25 out of 50 said, oh, I'm coming here to buy jeans, so I better order half of the pants that I order better be jeans. I would like you to answer this question on page 3 on your own. So this got it. Do this problem here on your own, and we'll go over that one when we come back together in class. Let's go to the next page. It Zach is trying to decide which of 3 golf courses is the best. He randomly surveyed people at a sports store. Okay, so they probably play golf, and recorded the results in this table. Is the sample method valid? Well, yes, because it's random, right? He randomly, so it's valid. Is the sample method valid? Yes, because it's random. That's important. If so, suppose Zach surveyed 150 more people. How many people would be expected to vote for Rolling Meadows? Well, how many do I have all together here now? I have 25. If he expected to survey 150 more people, so let's see, Rolling Meadows got 7 out of 25. So how many more if I added 150 more people? Well, times 6, that would be about 42 more people 42 more would vote for Rolling Meadows, right? Do equivalent ratios there? That would make sense. It's a random sample, so we can take our results of our survey and make a prediction about it. To find how much money the average American family spends to cool their home, 100 Alaskan families are surveyed at random. Of the families, 85 said that they spend less than $75 per month on cooling. The researcher concluded that the average American family spends less than $75 a month on cooling. Is this valid conclusion? No. I'm laughing here because, okay, people in Alaska, it's probably a little cold there. I don't think they spend a lot of money on cooling, and they're not the average American. What about those people who live in, let's say, Arizona, another A state? Very hot, or Florida, right? Gets pretty hot down there too. I bet they spend more money on cooling. Would this be valid? No, because Alaskans aren't an average American. They would have to ask, people in lots of different states to get that, right? It's much colder in Alaska than most other places in America, so the amount that they spend on cooling really doesn't represent the average American family. So that's not a valid conclusion. Silly question. And that's it for today.